So it's me, I'm Mohamed Gamal. I'm staff engineer at SumUp. If you ever heard about it, if you didn't, please visit our booth there. So today we are going to talk about a real world case study about SumUp, how we manage our projects, how projects deal with each other, the conflicts we have, the issues, especially with Poly-Repo dependency nightmares. And the agenda is, first there is a little bit of introduction about Android as SumUp. So we go through our mobile products, the architecture. Then we talk a little bit about mono and poly-repo patterns and the dependencies and issues we have. That's not all. That's why I reminded you about coffee. Then we talk about Gradle and the dependency resolution, version catalogs, custom plugins, and finally, com.sumup.plugins. No time to waste more. Let's go. So Android as SumUp. At SumUp, we have many products. That's not even all of them. So we have, first of all, Super App. The Super App, whenever you search on Play Store, SumUp, you will find the black logo with SumUp. That's the Super App. Also, we have something called Mobile POS SDK that we give the integrators so they can transact using the card readers, using SumUp solutions as well. We have Register, which is the POS. You will also find it in our booth. We have SumUp called Post Pro. We are not very interested about that because it's iOS. We have Kiosk, we have Pay. So what are we talking about today? Only the first two. So this talk will cover SumUp Super App and the POS SDK. So let's talk a lot about our high-level architecture. We have a repo, the main repo, that has all functionalities of the Super App, everything also about the POS SDK. And we have some other repos. So there is observability, lib, we have KMP, we have the authentication, we have the design lib as well. Those are other repos. So how it works is kind of monolith that's kind of modularized, hopefully. And we have some other repositories. So it's poly-repo in the end. So that takes us to another topic. What does it mean, monolith, and what's the default? Is Android monolith or Android is monorepo? Actually, Android by default is monolith. When you create a new project, it will create a monolith to you. What does it mean, a monolith? It means one repo that has one project, and this project has some modules. That's fine. You can modularize it. Monorepo is a little bit different. Monorepo is one repository that has multiple projects, and each project can be fully functioning Android. Let's talk here Android, Android app, Android SDK, whatever you are going to publish. So that's the main difference between just monolith and monorepo. Poly-repo is a little bit different. So poly-repo can be a mix of all, but mainly it's multi-repo, it's poly-repo. So that's, first of all, how it's architected. So SumUp is more into poly-repo. For some stuff, not for everything. And what's the best architecture? So I don't think there is a best architecture if you are waiting for that. I'm not sure. I will ask what's the size of the project that you have. Maybe it's a small project. Maybe you just have, I don't know, 10 screens. It's well modularized. So yeah, monolith works perfectly. If it's big, maybe monolith also works perfectly, but let's see some points of comparison. First thing, we'll talk about the components integration. So in the monolith, everybody knows how components integration work. You just have some modules. These modules communicate to each other. Hopefully, you do it in a very optimized way and so on. That's a different topic. For the monorepo, it's kind of the same, but instead of just getting the module, you just also need to pass the file path of the module. But in poly-repo, it's a little bit different and more complicated because you need to use one of two things. At least that's what I know about. Get some modules or you publish. So you use each repo as separate library or separate SDK, and you publish and you use as internal dependencies. The build time, who here suffers from the monolith build time? I think everybody's happy with the build time. It's only us at SumUp? Great. We need to do something. So the monolith is very well known, especially when the project is really big. It's very well known with huge build time, especially if you don't have sample apps for your modules, the big modules. Because anyway, you build the whole project together, which is a little bit problematic. For the monorepo, it's Different because you can build usually you build every project standalone unless it ended up, everything depends on the other, so it doesn't really help as well, only if you have sample apps. For the Poly-Repo, of course, build time is perfect here because you just have very, very small projects, each project in its separate repo. You just build small pieces, and only when you integrate everything together, you build the whole thing. About testing, it's kind of the same, similar to the build time, because you don't need to test everything together when you have Poly-Repo. About fast-paced development, that's a little bit problematic because define what's fast-paced. When you talk about the delivery, it has 2 points of view. You can deliver things by publishing your SDK, your library, and you can say, I deliver only when I publish the whole app. So it depends which point of view you are looking at. But of course, if you need to go quicker, you can do your changes all in some repo for a week and then publish all together and integrate all together. So this is also a gray zone, I'd say, the fast-paced. Complexity. First of all, the contribution. It's a little bit harder to contribute into Poly-Repo pattern because if I'm an engineer, I don't work, for example, on the app auth, but I need to touch it at some point of time. First of all, most likely, I will not know that there is a repo called app auth. I just get it by magic. So thus, the contribution is a little bit problematic when it comes to Poly-Repo, to be honest. It's easier for the other stuff because everybody is in the same project. Everybody knows, everybody reviews pull requests, so they know about other stuff. But in the monorepo, it's a little bit distributed, so it's harder to contribute. Same for domain knowledge, because if you don't review pull requests for the other repos, you also don't know how other domains really work. And the reusability. So if, as some, for example, we have some good functionality and we just decided to have an SDK that we publish to our integrators and we get advantage of that, I think Poly-Repo will be the best. If things are already separated, everything is very separated, you can publish SDK in a day, that's not a problem. When it comes to monoliths, that's a huge deal to do. When it comes to monorepo, it's kind of in between. But for reusability, if you want to reuse tomorrow the observability, for example, in another project, totally another project, like at SumUp we have something called Kiosk. No, we can't just publish it to, it's already published. Kiosk can just use it today if they want. We don't have the issues that we need to extract some code, build an SDK, publish the SDK, and so on, which usually impossible to happen, especially when you have huge legacy code. Get tree and releases. If you have a monolith that has everything, or a monorepo that has everything, just check your get tree. Like each change in any domain is gonna be in your get tree. Whatever, if you have a release, everything is gonna be together, so you cannot understand much from there if you wanna separate your domains, which is the opposite in the Poly-Repo. So what's the best architecture? It's all based on your needs and how the business really works. Because, yeah, I believe the business solution comes before the architecture even. So reminder about our high-level architecture. It's kind of Poly-Repo, but most of the functionality or the features happen in a monolith. Let's zoom in a bit, talk about our dependencies. So here, as you see, we have the repos that didn't change, the bottom layer. The up layer, we zoom in a bit. We have the app, we have the POS SDK, and the app actually depends on the POS SDK. It's kind of module. Here is simplified, it's lots of modules, but the app in the end depends on it. And this POS SDK depends on other modules, and the app also depends on other modules. Why is it a little bit problematic? Because we have some limitations for POS SDK. Usually anybody that publishes SDK or works in a company that does SDKs, you have some limitations because always the older versions you support is better because integrators don't want to suffer when you change some dependencies versions. We, at least at SumUp, we have 1 year backward compatibility window that you cannot use, for example, the newest Kotlin version. It needs to be 1 year old. So it's tested, reliable, integrators can use it safely. And we always ask ourselves, do we really need to pass this dependency to the integrator? It's a big question that we always ask ourselves and ask each other in the pull request. That's why sometimes in our project for sub-libraries, we have 2 different versions of the same dependency. One makes it to the terminal SDK, sorry, it's POS, but we call it terminal SDK, and the other one to the app, because we need the app still to be a little bit modern. We need to use the modern stack. We need to use Compose, for example. We cannot be stuck all the time just because of the legacy part. So sometimes we need to support 2 versions of the same dependency. And that's why we have some dependency nightmare. Why? Because as you see, each module or repo that contributes to the POS SDK needs to follow the POS SDK dependency versions. The app, the other modules that only contribute to the app, we don't really care much, because anyway, we can use the latest version, the latest stable versions there, so that's not really a big deal. But on the other hand, also the app and the other modules that only contribute to the app use the modules that contribute to the POS SDK, what makes the dependencies up. So for example, let's talk about Commons module. This Commons module has its own build Gradle. It implements, I don't know, activity X, and it uses the SDK dependencies because it makes it to the POS SDK. And it uses the version from there. If you look at the versions, you will find the SDK has version and the app has another version. So how does Gradle resolve this? So for the SDK, that's easy. This is the dependency tree. Okay, it uses Project Commons, and it uses the version normally. But this module also makes it to the app. Then Gradle needs to do that. It needs to change from 151 to 180. We'll also talk more about how Gradle changes and based on what it decides. And another issue with the Poly-Repo pattern here, it makes it more complicated, because if we have auth, and this is a separate repo, auth SDK or auth library, whatever, that uses version of browser 1.0.0. But actually, the app and SDK use different versions. So when this is integrated, that's even more problematic, because the dependencies are not aligned across the repositories, and you don't have control over that. It's not really a big problem if the low level has lower version, because anyway, Gradle will bump it, but it's problematic when it has a newer version. So if the auth has 2.0.0 and we don't need 2.0.0, Gradle by default will use 2.0.0, and this will make it to the app, will make it to the integrators, which is very unpleasant to us. It's a problem. Then, that's why we talk about Gradle. I think every Android dev loves Gradle. They create lots of issues and they try to sell solutions to solve them. We talk about the conflict. We have build Gradle of whatever the main project, and we use 1.0.0. And we have transitive dependency that uses another version of it. Then Gradle by default will bump it to 1.2.0. Why? Because Gradle just chooses, it picks the latest one, because it trusts that this library, SDK, whatever, is backward compatible by default. Very innocent. How can we custom it to use the versions that we really want, which is 1.0.0? Gradle has some custom resolution strategies. So you can force the version you want. So if you force this you apply to a whole project. So whenever it finds this browser, it will use 1.0.0 version, which is fine. What are the other resolution strategies? There is fail on version conflict. So whenever there is a version conflict, it will fail to build. It will not even start the build. And there is also prefer project modules, that it will use all the versions that are in your modules, not transitive dependencies versions. And there is also another thing that you can choose by the group of the dependency. So for example, the group com, Google, code, JSON, you can, for this whole group, force this version, meaning that whatever the dependency coming from this group, it's always 2.9.0. Resolution strategies are not the only thing that you can do. There is also dependency constraints that you can apply to the dependency level itself. How? You can, for example, use strictly when you add your dependency. When you add, for example, strictly 1.9, it will always strict the version to be 1.9 point whatever, but here it's 1.9. Let's take this example as this. And we can add some reason like, okay, I want to use it for compatibility reasons. There are also other stuff that you can use other than strictly. There is require. Require, whenever you put it, it will use the versions that you put, and any higher versions, that's not a problem. Prefer, it's like, if you found 1.9, cool. If you didn't find, I'm also fine with that. Reject, it rejects set of versions, and reject all, it will reject the dependency in general. You don't even need to specify a version. So that helps us to understand a little bit how to force dependencies or how to apply the versions that we really want to make it to our project. But how to share this? We want to share this across modules, for example. We don't need to keep repeating what we do. So we want something like, okay, whenever I put libs and droidx browser, it does whatever I already defined in this step. Here it comes to version catalogs. So version catalogs works in two ways. You can create your TOML file. This is not the version catalog itself, that's the definition of it. So you can put your versions, libraries, bundles, plugins, all of that, and then you create the version catalog from the settings file. So from Gradle, settings.gradle file, you can just say, okay, I will create the libs, and this libs, you get it from this file. Actually, if the file name is libs version TOML, it will be created by default. You don't need to do that. And take into consideration that files function, actually it should take a list, but it only accepts one file, otherwise it will throw an exception to you. So you cannot use one more than one TOML file. Cool. And you can create this directly from the settings.gradle without even dealing with the TOML file at all. You can define your catalog there, and whenever you build the project before the build, it will already build the catalog for you, and it will be used. So now we know how to centralize it in a monolith. So it's across the modules. It also can be applied in a monorepo, because you still can use the modules in monorepo, but this is not really usable in Poly-Repo. And here the problem, like here we want to solve the problem, because again, we are in Poly-Repo, we have different libraries internally. So have you heard of Gradle custom plugins? I'm sure maybe 90%, 95% know about it. So here we talk about, okay, how to create Gradle custom plugin that you can publish and reuse whenever you want, wherever you want. So easily, you can just in the root settings.gradle, you build a new module. Let's call it, I don't know, build logic, for example. And you add it to the root settings of Gradle. You say include build, because this is not just include. This you need it in the build itself, before the build. And then, okay, in this module, you create a file. It's a class called, I don't know, SumUp base plugin, for example. And you can do whatever you want there. It's a plugin of a project. We'll say later what does it mean exactly, and you can apply whatever you want there in this plugin. And then you register this plugin in your Gradle file, and then you can just use this plugin wherever you want. So here, for example, when I registered, I called it, the ID is com SumUp base plugin. That you can use com SumUp base plugin in any module still. Project. The project is the main API to use to interact with the Gradle, like for the build files. So build.gradle, this is project. And register, this defines a new object only when you start to need to use it. Like, okay, I will need it now, so then it will create it for you. Otherwise, it will not create, which is more efficient than create, because there is another keyword called create. Well, that's a project plugin. That's not settings. And we need to publish the version catalog. We need to use version catalog, which is something that you can only create in the settings.gradle. So here it comes to settings custom plugin. So you can have another module, for example, and you add, you register, put the module, include the build in your settings.gradle, and here you change the project. Instead of project, it's settings project. And you can do whatever you want. For example, here is a hint, apply com.sumup.plugins.settings.version catalog. For example, we created a plugin that publishes the version catalog, and we are gonna just apply it in this plugin, custom plugin. Then here you need to create or register, but we'll say why create. And you can use it everywhere. Settings is just the settings project. And the difference between create and register is that register will only create it once you want to use it, but create is different, and anyway, you need it in the settings, the Gradle, which already happens pre-built. So you need to create it anyway. It doesn't matter. Even if you used register, it's the same. Okay, some hints, because here we said, okay, we build 2 modules, and in each module we do our things, here for the settings, here for the project. I think it's better to have just one module that has all of your build logic, and you have 2 sub-modules, one settings, one convention, build convention, or whatever, and you just have in this module, in the build logic module, to include the 2 modules, and you include the build in the whole project. And why do we need 2 different modules, one for the settings and one for the projects? For 2 reasons. First of all, it's cleaner design. Second thing, to be honest, it doesn't work, and I don't know why. Gradle throws some error when you have everything in one module, and it doesn't say much. So just based on experience, still haven't learned why, to be honest. It just doesn't work. Okay, so now we created plugins. How can we publish the plugins? It's very easy. This is the easiest part. You can have your own GitHub packages. So you have a repo, or you can publish wherever you want, S3, bucket, whatever. And you just use the publishing keyword, which is extension already from DSL. And you identify what's the name of the repo you would like. The name really doesn't mean much also. And you put the URL of it and your credentials, and then once you publish, it's published. It's somewhere that's shared, and you can use it from wherever you want, in any repo, in any project. You can just use it. Most important, don't forget to put a version for that. And once you run Gradle W, build logic, settings, publish, it will publish it. And then you can use SumUp base plugin 001 in any project. You just don't forget to add access to the repo to download it as a Gradle, as a Maven repo. Okay, here it takes us to com.sumup.plugin. So we learned that we can use version catalogs. We learned that we can centralize our versions across the whole modules in a project. Then we learned that, okay, we can do actually settings plugins, and we can publish these plugins, and these plugins can publish version catalogs for us. We'll learn more about this. Then everything is applicable. We can finally centralize the whole logic of the dependencies. But Gradle has some limitations. First of all, you can only create version catalog before the build, but you cannot read it, of course. That makes sense, because you add this code to the settings, and the settings have, it gets executed before the build itself that creates the version catalog for you. So you cannot access the version catalog before the build. So in settings, you can just create, but you cannot read. That taught us something that, another limitation. You cannot use this function from files in a plugin. You can only use it from settings.gradle, and I don't know also why, but you cannot just use it. You will not even be able to include it. Another thing which is also logical, if you create your version catalog from TOML file and you published it, and you want to use it in another repo, this other repo needs to have the TOML file as well, because your plugin processes a file, and this file is not there, so otherwise it will fail. That also taught us a little bit that we cannot use really TOML file. We cannot really depend on them. So, a reminder of our main issues: the app versions versus the SDK versions, and it ended up with lots of mess in the dependencies and lots of conflicts that Gradle needs to resolve, and how to share these versions across the libraries and SDK. Can really Gradle version catalogs and plugins help us? I mean, otherwise we will not be talking today. So luckily, yes. So what was our goal? Our goal is to have one version catalog is being built, created before the build takes place. First. Second thing, devs don't need even to know where the dependency or the version is coming from. Is it related to the SDK? Is it related to the app? They don't need to care about this. I work for a platform team, so we need to care about this. And the last thing is that we need to share these dependencies across all the projects so it can be reused. Something like that. So we have POS SDK compatible versions, app-compatible versions, and we base something we call baselibs version catalog, and we publish, and people just use baselibs wherever they want, and everything is shared. So the plan, instead of managing dependencies from the highest level, we manage them from the lowest level. We create lowest level in our architecture, and we manage the dependencies from there. Something like that. So we have a new repo. This repo, let's call it build logic. And we have other repos. They all depend on it, and also the highest level still depend on it. So whenever you want to update a dependency, whenever you want to update a version, you go update there. So how did we deal with Gradle limitations? First thing, yeah, you cannot create a version catalog before the build. You can, but you cannot read it. That was what we said already. But that means we cannot create a default version catalog and update it if it's POS SDK, for example. Why this is a problem? Because the main idea was, okay, we have the default one, this is the app, and whenever the build is SDK build, we just change it and we deal with it. But actually, we cannot read to change, we cannot update it, we cannot read it at all. So that was one limitation we have. Another thing about the TOML file that we cannot really share across the repos, it will end up having the same TOML file everywhere, which is having the dependencies everywhere. This is a problem. Now we didn't centralize anything. So anyway, we cannot depend on it. So we needed to build our own data structure for that. How did it look? We built data class version. It has name, value, declaration. The declaration is default, strict, require, prefer, reject. We don't really have reject all. We don't need it. Library, bundle, plugin, and catalog. The catalog is list of each. And we built an enum called, wait a bit, yes, called version definition. The version definition has the reference, the app-compatible version, the SDK-compatible version, if needed. Otherwise, it's null, it's fine. And we have library definitions that use these versions, same for plugin, same for bundle. But we needed some helpers for that. So first of all, before the build, we just used to have system properties that we passed. Like, for example, we want to build a project, so then we pass this system property. Is it terminal SDK or POS SDK build? If yes, it's true. Otherwise, we don't pass it at all, so it understands that it's false, so it will load the correct version catalog. So loading the correct version catalog is not the problem here, but we need, okay, how are we going to use these definitions? We need some helpers for that. So we agreed that we will have a custom plugin, and this custom plugin is a settings custom plugin, so we need to build an extension for that, which is called create baselibs version catalog for me, just passing the catalog that we just created here, the bottom, the catalog data class. So once we pass it, it will create baselibs after it builds the baselibs. How does it build the baselibs? We just pass the catalog. It's extension to the version catalog builder. The version catalog builder is the one that inside the settings. So whenever you have dependency resolution management, version catalogs, this is a builder itself. So we built an extension to the builder that just adds the libraries, adds the versions, adds the plugins, adds everything for you. So when it adds libraries, it will just convert this to the Gradle library. Same for version with the right declaration, and same for the other stuff. So after we do that, and after we use these extensions in our plugins, we are able to, luckily, publish 2 settings plugins, one SDK compatible, one app compatible, but we forgot about the base version catalog. We changed this architecture a little bit because we found that, okay, if I have a repo and I know that I'm building the libraries that will make it to the terminal SDK or the POS SDK, that anyway, we need to use the POS compatible versions anyway by default. And the other way around, the only part that cares about which one to use is the highest level. So we need just to have this in the highest level. So we change it. And yeah, anyway, you change the plans. Then it's done. We publish. We use the published ones in all the repos. And that was really amazing. We built some automation for that. So whenever you open a pull request in the build logic and you add a flag, okay, it will just bump the app version, commit this for you. Once merged, it will publish it directly, and then it will announce in Slack, and it will open PR in the highest level project to bump the version. Life is amazing. Everybody was happy. I remember when I announced this, it was a Friday. It was very happy achievement. And then got a Slack message on Tuesday. That's exactly what happened. So what changed? Because we focused too much on building architecturally correct solutions that centralize everything and so on, but we didn't really think about the developer experience. What? Why? Just imagine 2 engineers publishing the version catalog for updating 2 different versions. One of them is problematic. It was untested. So first was untested. Second was okay. Anyway, when you publish the second, you publish them both together. Then it ended up with a big chaos. Who fixes what? Who does what? 2 versions are broken. So it slows down the whole process. The other stuff is even more problematic because we say it, like you have the lowest level that controls the build, then some repos, then the project. So just imagine you want to update some version in the middle layer. It needs you to open a PR in the lowest layer, snapshot, test the snapshot of your SDK, then put it in the highest level, and then if all work, continue, which already very slow. So the plan was, okay, instead of managing everything from the highest level, we manage everything from the lowest level. We thought that we were very smart, but actually it was not a smart idea at all. Then we needed to reconsider the whole plan. Okay, what did we really want? We wanted to centralize the version catalog. We wanted to reuse it. We want engineers to not care about what versions they use. We don't want Gradle to fix versions conflicts all the time. We want everything to be predefined before the build. And we want to share these version catalogs. In the beginning, we didn't want to have things in the lowest levels. That was just solutions that we invented. So we went back to basic. Then we decided, okay, we don't need the lowest level. We put everything back to the project, and we publish from there. So whenever you want to update a version, you update it in the main project, and anyway, it will be published, so you can use it in all other SDKs, repos, or whatever. That means that it's centralized in the main project. Whenever you want to update, it's tested, because this is the main project. And whenever you merge the PR, it will be published, announced, and other integrators, internal integrators, can use it. So we didn't need to go crazy as we were before. Then, okay, if I'm an engineer, I want to update one dependency in my own library. What to do? Nothing, just go to the main repo, update the version. It will be published automatically. It will be announced automatically, and done. You guarantee that everything is tested. The PR has all what you need. So just a PR, all what it takes to update one version that's shared across all the projects in the Poly-Repo. And about the issues, now there are wins. So the main issue, the first issue was app versions versus SDK versions. Okay, now it's initialized before the build anyway, so you don't care much about that. And engineers don't need to worry. They just use versions. They don't care this version is coming from the SDK, this version is coming from the app. It's centralized anyway, so they don't need to care about that. And also, not only versions, but also libs, plugins, bundles are shared across the whole Poly-Repo. So all the repos can use the same, and it's really easy to contribute. Again, one PR is all what it takes. That's all. So, any questions?